All right. Hello, everybody. Good afternoon. Thank you very much for attending this session. I hope you have been enjoying the OpenStack Summit so far. My name is Jaromír Coufal. I work as a product manager for OpenStack at Red Hat, and I'm here with my colleague Steve.
Hi, I'm Steve Hardy. I'm a software engineer at Red Hat, and I've been working primarily on the O project for the last few years.
And in this session, we would like to give you experience or share experience when we are containerizing OpenStack deployments, what are the challenges and how we are approaching them. Just a couple of slides of level setting here. You are probably all aware of benefits of containers. So if you imagine you have application composed from two services, each service is consuming its own libraries, which are running on baremetal. There are potential version conflicts of those libraries. So making the specific environment for each of those services so you can deploy them independently, but also run operations on them independently is one of the biggest benefits for containers. If we look into OpenStack, we can treat it the same way as the application, traditional application. Of course, it is much more complex and much more distributed, but the fundamental benefits of containers can apply the same way in the OpenStack environment. So the end goal is to take the OpenStack environment and isolate the services as independent applications so we can deploy them and manage them independent on each other. There is multiple projects in the OpenStack community which are deploying OpenStack in containers, but the real challenge is not to deploy the OpenStack in containers from scratch, but how you move or transition the users from the current model, from baremetal deployments, to the new world of containers with minimum to zero disruptions. And that's the challenge which we are facing as of the moment and which we are trying to address within the O project. So within the O project, we approach this with multiple phases and with incremental changes. We are trying to guide our users through this technology evolution. So there is 3 phases. First phase is to create microservice environment to make every OpenStack service being deployable, updatable, and upgradable independently on each other with their own scripts. Then take this environment and change the runtime of the applications of the services from baremetal to containers, keeping the same orchestration layer. And as the third phase, change the orchestration engine to Kubernetes and basically reach the end goal. And our promise, or what we are trying to achieve, is to keep the same interfaces, top-level interfaces, unchanged, so that users, when they are having automation on top of O, will not feel the impact of the underlying evolution of the technology, and also to provide updates and upgrades between these multiple phases so that we can move users from one release to another. And we have faced multiple challenges throughout the way, and Steve will talk a little bit more about those.
Sure, thanks, Jarda. So I'm just going to dive a little bit more into the details, and that's hopefully sort of frame the problem for you, which is that we have had a number of generations of O, and we've made significant architectural changes, and we've got real users who are using this stuff to deploy their production clouds, and we really have some strong constraints around backwards compatibility for that reason. And so, initially there's just kind of like just some pros and cons to be aware of, and Jarda's done a nice job of explaining some of the reasons why you would want to move to containers, the dependency isolation and the ability to do service-by-service upgrades, potentially much easier rollbacks when you do need to make a rollback during an upgrade procedure. And also, there's a lot of interest within the OpenStack community in terms of container orchestration on Kubernetes and other tools. So, it's a nice stepping stone to that, getting to the microservice-based model and improving the images. And we've benefited hugely from the work done in, say, the Collar community, where we're using the Collar images and orchestrating them via the O orchestration framework. There are a few challenges which we run into, and one is that because of the isolation, even with layered images, you end up with quite a lot of data to download when you're doing major upgrades. And when we're switching from the bare metal environment to the containerized environment, you need to download all of the containers in one hit prior to doing the upgrade. So we've built in a system which allows you to run a local Docker registry on the undercloud, which is the provisioning node part of OOO. Obviously, you could run another local Docker registry as well. There's also a few changes around the sort of logging and monitoring framework. We had integration with Fluentd and Sensu, and we basically made a few concessions to our sort of bare metal environment, such as bind mounting log files onto the host, and a few other things which I'll go into on the next slide, just so that we've got this incremental approach where we can switch to containers, but minimizing the risk of regressions. The other aspect is config management. So we've had a fairly traditional approach to config management using Puppet throughout multiple generations of OOO and previous deployment projects at Red Hat. And for that reason, a lot of the vendor integrations and hardware enablement, and also field customizations are performed via Puppet. And so in order to avoid breaking the world with this move into the bold new world of containers, we've actually got a two-step approach where we'll generate the config files using Puppet in a temporary container, and then we'll write the config data onto the host file system, and then we'll launch the service container. And so again, this is an approach which has allowed us to really just split the problem into two halves, where we've maintained the config management layer of OOO completely intact for this release, but we've got the isolation provided by containers. So it may well be something that we'll iterate on in the future. It would be nice to remove some of the pieces of technology to simplify the stack, but the main aim at this point was to allow us to make progress towards fully containerized deployments whilst minimizing the risk to our current users. That's worked really quite well for us. We're also using Puppet for some bootstrapping, such as creating Keystone endpoints in Keystone database. The other thing which we ran into was the image build pipeline. That's a bit different to building RPMs, and you need to either do periodic rebuilds of everything or know how to know which things to rebuild when a certain thing contained in the containers change. Collar provides some nice tools which we're reusing in the upstream OOO CI, but it's definitely something you need to bear in mind, is that your CI pipeline is going to look a bit different when you're rebuilding container images rather than consuming packages. The other challenge, which Yada has already mentioned, is in-place upgrades. And that was really a hard requirement from day one for OOO. We had existing bare metal environments in the field, and production users of it. So our approach to that was, again, go for the least risky option, make this transition, and try to avoid any breakage of those existing deployments. So the approach we took was for stateful services. We've left the state, as in the files, the database files, for example, on the host, and we bind mount those into containers. Again, this is a nice stepping stone. It will probably look different when we get to deploying on Kubernetes, for example. But it allowed us to focus on the dependency isolation. We shut down the service on the bare metal and disable it, and then we have some Ansible tasks that make some bind mounts and directories on the host file system, and then we run through the normal deploy steps, which is basically the same Ansible-based orchestration that we use to deploy the containers on a greenfield deployment. We also use using a major upgrade. So this has allowed quite a sort of a reduced risk approach to the major upgrades, and so far it's working quite well for us. It does require control plane downtime, but the tenant workloads are not impacted at all. In the future, we're definitely going to be looking more into allowing rolling major upgrades. A bit of a challenge there is that not all OpenStack services currently support it. And so just to kind of wrap up, it's just our approach to incremental migration, and it has just been, to try and avoid making more changes than we had to get from the bare metal to containerized environments. We have continued to use host-level networking because we had quite a featureful environment where you can have network isolation per service in OOO, and we didn't want to break that, and the container networking models would make that a bit more difficult, at least in the short term. And yeah, reuse of the existing config management tool chain was another way to avoid the risk of regressions. We've also enabled hybrid deployment, so you can actually deploy Puppet configured services on bare metal mixed with containers. That's useful, for example, if you've got vendor integrations which are not yet ready to be run in a containerized environment. So that's kind of, again, a stepping stone which has allowed us to make progress this release. So that's basically all I have. This is a link to our documentation, and we're also on Freenode if you want to catch up with us. So that's it. Thank you very much.
Thank you very much.